Hi and welcome back to Module 7, Organic Chemistry, and today continues our series on naming our organic compounds. And today's functional group is the carboxylic acids. Now, while we call them carboxylic acids and they are our common name, our correct or more correct IUPAC name is our alkanoic acids. So the outcome that we're going to look at today is investigating the nomenclature of organic chemicals up to C8 using the IUPAC conventions, including simple methyl and ethyl branched chains. So the biggest way to remember these ones is the Q group, COOH, and these groups only can form on the end of a carbon chain. And this is known as the carboxyl group, not to be confused with the carbonyl group. So our carbonyl group is just our double bond O. Our carboxyl group has the C double bond O, but it also has an OH bond also off that same carbon, as we can see down here in our picture. So here is our hydrocarbon chain off the end, off that end carbon, and so we can see here that this is our terminal carbon with our double bond O, and then our hydroxyl group off the side. So it has to be located on the end. Now, why do you think that might be? So if we think about the number of bonds that a carbon can have, we have got two coming up here to the oxygen, one coming down to the hydroxyl group, and another one going off onto to the rest of the hydrocarbon group. If it was to be placed on the inside where it would be attached to two C's either side, we don't have enough bonds there for it to occur mid-hydrocarbon. So it can only occur there on the end of the hydrocarbon chain. So when we name this, again, we are naming it with the hydrocarbon being at the lowest number, so it would be number 1. And of course, because it is placed at number 1, because that is the only place it can be placed, we don't need to worry about a number with our naming system. Now, the same principles apply with all the other naming conventions that we have done to date. The only difference here then is our ending ends in oic acid. So our smallest carboxylic acid is our methanoic acid, which is in fact this one that we just have here, where we have one carbon and one carbon attached to a double bond O and an OH on the end, and it's our methanoic acid. Now you'll notice that we're using the word acid, and if you can remember back to our Bronsted-Lowry, it's the ability to donate a proton, and when it actually donates its proton, it is actually donating its proton from this hydrogen at this end here, not from the rest of the hydrocarbon chain. So let's have a go at naming a couple, and on this one here, you can see that if we count through, we have got 2 carbons there, so that's immediately telling us we are looking at the eth group, 2 carbons with that prefix. We're looking again and noting that we have our carboxyl group off the end there, so it's an ethanoic acid. We have no double bonds, no triple bonds, or anything else to worry about because it occurs on the end. It is therefore our ethanoic acid. No numbers are required. Short video today with only one naming group, with many of those principles that you have practiced so often to now. We'll practice more in class tomorrow, and I'm sure you'll be an expert. See you then.